Hi, good day. Today we will continue with chapter 4, interpolation. So today I will explain to you and or discuss with you the first interpolation, that is a Laglash interpolations. So this is chapter 2. Basically, interpolation, we have two methods. One is polynomial interpolations and another one is piecewise polynomial interpolations. And for the polynomial interpolations, there are two methods. The first one is Laglash interpolations and the second one is Newton divided difference methods. And for the piecewise polynomial interpolations, actually is have two methods, with natural cubic spline and clamp cubic spline. But in your syllabus, the topic that cover is only Lagrange interpolation, Newton divided difference, and only natural cubic spline. This the clamp cubic spline is not covered in your syllabus. So let's start with the Lagrange interpolation. Okay. So, Laglash, okay, what is an interpolation? Basically, okay, let's say we have a set of data. Okay, normally Lagrange interpolation is we want to estimate a missing value. Okay, let's say we have a graph like this. Let's say we have a graph like this. And then we have a point. Let's say we have 1 point, and then 2 point, and then 3 point. Let's say this point. And this is the value of, let's say this one is x naught, f x naught, and this is x1, f x1, and this is let's say x2, f x2. Okay, so let's say we want to find let's say we want to find at this xk, what is the value of y? Let's say we want to find at this point, okay, what is the value of this fxk? So we can estimate this the value of x fxk using the interpolations. That means we want to make sure that the polynomial is passing through all the point here. This point, and this point. Is this point, and this point. And then we find the value. So that means Lagrange interpolation, basically we want to find a missing function value. It's actually we want to find or estimate missing function value. Okay, value. Let's say this is one of the fx lah. This is the function, one of the function. This is a polynomial. Okay. So what is if let's say when we have it depend on what polynomial is it, how many order. Okay, let's say this one, go to this one just now. This example, we have 1 data point, 2 data point, and 3 data point. Okay, when we have 3 data points here, okay, we have 4 data points. So this is actually second order polynomial. Sorry, 1, 2, 3, 3, 3. This is 3 data point. 3 data point. This is second order polynomial. So this is the P2x. We can say it like that. So how we define whether this one is the what order? So we can depend on the when we want to find the polynomials that going through all the data point. So we can look at how many data points and see on the what order of that polynomial. For example, this one 3 data points. So because the polynomial is based on n, polynomial is equal to sorry, the polynomial it is n plus 1. Okay, it's become the data point. How many data point? So this one is second order polynomial, and plus 1 is because we have a 3 data point, right, for this example. So basically we can find the polynomial that's going through all the data points using two methods, using direct, that is a Laglash, this one Laglash interpolation, or using Newton divided difference. Okay, so let's go to the linear. Go to this one. The first one, let's say we have a linear line. We do a linear approximation. We do the linear find the interpolation in the linear polynomial. Wait, I see the book. If you have a book, Lagrange Interpolations, okay, if you want to do the linear approximation, you can turn to page 75. This is a linear approximations. So basically linear, that means that this is a first order polynomial. So if let's say this is a first order polynomial, there's a graph is like this. We have a class. So because this is a first order, that means we have two data points. Let's say we have this one. 1 point, 2 point. So the graph becomes something like this. Okay. And then we want to find one of the value here can be. Okay. To get this value. What is this value? Let's say this is x. Okay. So this is linear, first order. Let's say we second order. Second order, that is a quadratic approximation. Quadratic, sorry. Quadratic. This is a second order. Okay. So for this one, the graph is something like this. Let's say we have a graph like this. Okay. Let's say we have a 3 point, the 3 data points, because this, okay, this one is 2 data point. 2 data point. And this one 3 data point. And let's say we have like this, or maybe can this, and then we can this. So we have graph like this. Let's say we have graph like this, passing through like this, passing through different point. Okay, so maybe we want to find one of the value between this, between along this polynomial. So it can be like, for example, here, let's say here, want to find the value of this one. Okay, let's say third order that is a cubic. Third order, so that means we have 4 data point. Okay, 4 data points. And the graph can be like this. Let's see if we have the graph like that. Let's say like this, we have a point like this. The graph can be like this. And you want to find one of the value over here, let's say. Then maybe another one is a quadric. Quadric. Quadric, that is the fourth order. That means it's this means we have 5 data point. So for example, let's say a graph like this. 1, 2, 3, 4, 5, let's say. And the graph will like this, look like little bigger. Something like this. And we want to find the value of x, let's say here. So what is this value? The value of y. Okay. So if let's say this is a linear, okay, the process, okay, with a Lagrange interpolation is actually we call Laglash, okay, interpolation, because this is a process of estimating or approximating a function fx, and we estimate the missing function value. So in the interval, within the interval a and b. Okay, so let's say we have go back to this one. Let's say this one, linear equations here. If let's say here we have x naught, x naught, y naught. This one will be x1, y1. Okay, and here we have 3 points. That means x naught, y naught, x1, y1. This one x2, y2, and so on. Okay, so let's say we have the value start from x naught, y naught, x1, y1, until we have xn, yn. So depending on until what order of that functions, okay? So the polynomial of functions, the functions will be f and x, okay, equal to polynomial is a summation of, for the I equal to 0 until n, li x f xi, where this one, okay, this is the function, or this one function is equal to polynomial. Okay. And this one is a weighting function. And here, this is the value of data at x point. Okay, so what is fxi? So fxi is that means that is the value of y. This one, fxi is actually is the value of y. This one lah. So if let's say this one, go back there. This one. If let's say this one y2, here this means this is this actually is fx2. Okay, this means y2. Okay, so fxi that means is the value of y. For example, you will have y0, y1, y2, and so on until yn. Okay, so what is this one? Wait, it look like a bit blur. I put it in wait, I bring this whole thing to the wait, this one bring to down. Oops. Okay, I paste in here. Let's bring this one to go down. Okay, continue. Okay, just now we go. Okay, just now we weighting function. What is this weighting function? This weighting function. So the weighting functions okay is actually Li x equal to a product of this is a product of I equal to 0 j sorry it's j equal to 0 and j is not equal to I from j equal to 0 until j equal to n for the x minus xi x minus sorry not xi xj xj divided by xi minus xj. Okay, so the products of that mean it will times. Okay, let's say I do this one example. I use this symbol. Okay, let's say I want to find the product of okay start from I equal to 0 until let's say until 3 for um for x squared. Let's say this one. Okay, so that means this one xi. Okay, sorry, it should be I lah. I put I. Okay, xi lah, xi square. So it will become like this. If let's say this this one. I use the function the product of, okay? So that means it will become start with x naught, okay? This I is start from 0. Okay, this means this I will have start from 0, 1, 2 until 3 because this one is the last one, okay? And then based on these equations, okay, so this one will be like this, and will be times with x1 square times with x2 square times with x3 square. It's like this. It will multiply until n. Okay, so this is the meaning of the product of. Okay, so can I delete this one? So I just delete this one, okay? So I just delete this one. Okay, then let's continue. Okay, so it's depending on how many data point. So if let's say this is a linear, linear, that means we have two data point, right? So that means the n is equal to 1. So that means we will have the value will has x naught, y naught, y naught, and then x1, y1. You look at here, why I said n until 1 is because here we will start from 0. That means we only have 0, 1 until 1. This is two data point, right? This is a 1 point, one data point. This is the another. This is a first, this is a second data point. Okay. If this is a second order, if let's say second order, just now go back. So this one, you see, we have this one, you have one data point, x naught, y naught, x1. So the n is 1. So when we have for the second order polynomial, okay, let's say we have three data points, that means the n is 2, okay? So that means if you look at here, we will have x naught, y naught, x1, y1, and then x2, y2 until 2 only. Okay, so same. If let's say we have four data point here, 1, 2, 3, 4. So that means the n is 3. So we will have x naught, y naught, x1, y1, x2, y2, x3, y3. Mm. Okay, if let's say we have five data point, that means the n is equal to 4. So we will have up to start from x naught, y naught until x4, y4. Okay, so if let's say we want to do the polynomials, okay, so we go back to this one. After we get based on how many n that you have, then you will have to multiply the functions, this one multiply. Okay, so that's we can expand. Okay, let's say we expand these weighting functions, and we expand this function, we expand it, so it can be like this. Let's say this is the linear. Let's say this is linear. Then the Lix will be, because we only have two data points, so that means x minus x, x what? X naught, start from x naught. And then we will start from the x1, this one, divide by, wait, I go back again. So this one will be, x is the value that we want to find, this one. X, this one is the value that we want to find. So we'll put x minus xi. So xi, just now it said si is equal to 0, but it uh, cannot same to I. But I will start, normally we will start from the x naught, so it cannot be same. So x1 have to be, after this one for the linear, we only have, if let's say linear, we only have x0, y0, right? x1, y1. So we only have this one. So here become, we cannot x, the I cannot be same with j. So this one will be x1, okay? So this one time with, this one is same, okay? And then x minus x naught, and this one x1 minus x naught, like this. So the I here, we have start from the 0 until 1, because here, so here the ends, if the linear n is equal to 1. So that means we have 0, we start with I equal to 0, and then I equal to 1. I equal to 0, I equal to 1. Look at here, I. Okay. So, and then xi minus xj. You look at here, this one is xj, this one is also xj. This is the value where we don't know. We know this value, but we don't know the y value. So we want to find the y value at this point. So it will be x minus x. So you don't know whether you want to put 0 or 1. So you can write the bottom part first. Then the bottom part I, normally we will start with the 0, which is more easier. So that means x naught, x0, x naught minus x1. So the above here puts x minus, so it used to be same. This one, these two same. So after x naught, and then the next one you have to multiply with I is 1. So x1 minus x naught, and then x minus x naught. Okay, this is the, when we have two data point. Okay, if let's say, if you have 3 data point, okay, that is a quadratic. This one, go to this one. If let's say we have 3 data point here. So the Lix will become, okay, so I will start with this one, x naught minus x1. So this is x minus x1, okay? And then time with x1 minus sorry. So one more thing is x naught minus x2, okay? Okay, x naught minus x2. And then this one x minus x2. And then time, sambung time. Okay, this one is based on wait this one is, let's say we start with the L naught. Sorry, this one. We have to expand until, okay. Let's say this is we, if let's say we start with the L naught. Okay, so this until here only. Until here only, if let's say L naught. Okay. If let's say L1 X, then we will have to start with the X, okay, X1 minus X0, this one, time with, okay, this one X1 minus X2. Okay. When we want to do L2, that means X minus X1, sorry, X0. Okay, dia tak boleh tolak dia sendiri sebab sekarang 2. Okay, so now is X0, and now we time with the, because this one is X2, okay, X2 minus, dia tak boleh tolak dia sendiri. So we have X0, X1, right? X0 already, and then this one is X1. So here is x minus x1. Okay, so depending on how many n we have, for example, this one, the n is, this is n is 2. So we will have L0, L1, L2. That number of L also will depend on this one, these weighting functions. So go back to just now. I think this one I have to explain more based on this one. Then you will be more easier to understand. So if let's say just now, this one linear, okay? Okay, repeat for this linear. So it's this linear. That means for the weighting function, we have depend on, because the n is 1, right? So we have to do L0, okay? L0 x, and also L1 x, okay? The weighting function for 2. One is 0, another one is not 1. So this one, if let's say this one, it will become x0 minus x1. This one x minus x1. And this one will be x1 minus x0, x minus x0. Okay, so you can understand or not. So if let's say this, we have 4 data points and then n is 3. That means you have to calculate L0 x, L1 x, and then L2 x, and then L3 x. So that means here, because we have, let's say kita ambil this data point lah, x0, right? So start from here, x0 minus x1. Okay, this one x minus x1. Okay, time with x0 minus x2 pula. So here this is x minus x2 time with x0 minus x3, this one. So here this is x minus x3. Okay, so in this one will be x1 minus x0, x minus x0 time with x1 minus x2. x1 tak boleh minus x1, okay? You cannot minus itself. Okay, and then one more, x1 minus x3. Apa yang ada? Kita dah ambil yang ni. So, kita kena yang this one, and this one. So, x minus x3. Okay. This one, that means x2 minus x0, x minus x0, time with x2 minus x1, x minus x1, time with x2 minus x3. So here is x minus x3. So for the L, for the weighting function, this one L3, x3 minus x0, x3 minus x1, x minus x1, x3 minus x2. So x minus x2. It's become like this. So kalau nampak if let's say lagi banyak data point, yang darab tu product of tu lagi panjang. So you look at here, when this is a linear polynomial, first order of polynomial, linear approximation, n is 1, dia satu kali je lah. Okay, satu kali. Apabila n equal to 2, you look at here, this one will become, we have like 2, this one, 2 kali. When n equal to 3, 1, 2, 3. Okay, so, okay. So we continue with this one. This is the weighting function. And after that, in order to find the polynomial of functions, from this weighting function, we have to time with the value of y. Okay, so that means, kalau lah sini, untuk lah linear polynomial, here, this one. Okay, so that means the function fx or sama dengan, for this one lah, P1. Okay, kenapa saya letak 1? Because this one, n is equal to 1. X is equal to, okay, so maksudnya saya kena L0 X have to be time with F0, ataupun boleh tulis Fx0, plus with L1 X time with F x1. This is the value of y, okay? Value of y. Y0, this is a y1, okay? So, sama dengan kalau saya kembang lagi, saya ganti masuk this value x minus x1, x0 minus x1. This one, f x0. Plus with, this one is x minus x0, x1, sorry, 1 minus x0, f x1. So, macam ni. So, that means you have to substitute the value of y here, substitute the value of y here, substitute value of x1, substitute value of x0, x1, okay? And the value of x yang mana? Kat mana kita nak? Let's say here. Let's say this one is x0 is 1. This is 4. So, katalah sini x is 2. So, we have to substitute value of 2 here. This is 2. Okay, and then here, this is a 1, this is a 1, this is a 4. Okay. So if let's say this one, when we have 2 data points, that means our function, our quadratic approximation, okay, that means the function will become like this. Fx equal to P 2x. Okay, so sama dengan Lx x L f naught plus with L1 x f x1 plus with L2x f x2. Okay, kalau kembang lagi, right here, so become salin atas. So bring this one, the whole this one. So it become x0 minus x1, x minus x0, x1 times with x0 minus x1, x minus x1, okay. Sorry, this one x1 already, it is x2, sorry. So time with f x0 plus with this one x1 minus x0, x minus x0, x1 minus x2, x minus x2, this one f x1. Tambah lagi. Nanti masuk yang this one pula. This one. Okay. x2 minus x0, x minus x0, x2 minus x1, x minus x1, lepas tu f x2. So become like this. So become very long. Okay. So then we can get the answer. Okay. So do we need to explain more on quartic? So quartic will be a very long one. If let's say this one. Just now I only try until this cubic only, third order. If 4 orders, that means we'll have another one here. And then we have to add all this one, L0, L1, L2, L3, and L4. Okay. And with the value of y itself. Okay. So maybe I start with doing the exercise here. So look at exercise. If let's say in your book, exercise 4.1 is also will be a very long one. Okay, exercise 4.1. Given the following data, which is generated by the function y equal to 1 over x, and we have the data point like here, the value of x with the value of y, and then it asks you to approximate the value of y when x equal to 4.5. That means f 4.5. That means, okay, here lah, when we have 4.5 here, the x, and then find this value of y by using linear, quadratic, cubic, and quartic Lagrange interpolations. Find the absolute error for each approximation. So this is the exact solutions, the value of y. Okay, so if let's say the exact, so here are the solutions. because here it asks you to find the absolute error. So that means absolute error is the exact solution minus the approximation, right? So solutions, okay. The exact solution, exact value is y equal to 1 over x, okay. So equal to 1 over the value 4.4, 4.5. We want to find the value of y when x is 4.5. Let's use calculator. 1 over 4.5. So you get the value, the exact value 0.2222. Okay, this is the exact value. Now we want to find using approximations, using Laglash. So start from the linear. Linear, okay. Linear approximations. Let's say linear sini, linear and you need 2 data point, right? 2 besarnya. 2 data points, okay. So that means if let's say here 4.5 is here, that means we will use this value and this value to approximate this 4.5, right? The value of y when x is 4.5. So that means we will fix this value. We will take the value of 4 and 0.25 and also the value of 5, 0.2. Okay. So that means this is a x naught. This is a f x naught. Okay, and then this is x1 f x1. Okay, so we want to find fx. So now it's p because n, this one n equal to 1, right? So p1x, okay, equal to l naught x f x naught plus l1x f x1, okay? So L naught, the weighting function. So L naught will be start from x naught minus x1. Okay, so this is x minus x1. Okay, time with the value of x naught here plus with, okay, for the L1, x1 minus x naught, x minus x naught, f x1. Okay, now I want to find the value when this one 4.5. So saya akan ganti masuk. So it become, the equation become like this. P1 4.5 equal to, so this x is the value that one will 35, 4.5, this one, minus x1. So x1 is this one, 5, divide by x naught is this one, 4. 4 minus 5, okay. F x naught, this one, this value, 0.25 plus with x is 4.5 minus x naught is 4 divided by this one, x1 is 5 minus 4 time with fx1, that means 0.2. Okay. Okay. So, and then you calculate. So maybe it will easier if you use the calculator, and let's say we assume the calculator, let's say we make the ABC. Okay, so x, let's say x, we make this become 4.5. So x naught, you make it become A, and then x1 become B in the calculator. So in here, this one, this one, this is x. Sorry, I draw this one. This one you can put in the calculator like this. because now it's easier. But when you have a lot of this n, that will be longer. So you put x minus a divide by, sorry, not a, b, minus b, and then this is a minus b. Okay, so let's do this one. This is alpha x minus alpha b. Okay, and this one is alpha a minus alpha b. So tekan calculate. So what is x? X 4.5, and then b is 5, a is 4. Okay, so you get this one is 0.5. This one is 0.5 time with 0.25 plus with this one. Calculate again. Calculate again. Now I just change. If maybe I just use the same equations. L even to change, then it will be, you have to change others lah. Become this one is b minus a, x minus a. So it doesn't matter. We just use, now you just twist. This one, twist. Okay. X is still this one. And we are calculate. X is 4.5. And then b is now is 4. C, a is now 4. A is now 5. So 0.5 as well. Kalau nak calculate biasa pun boleh. Cuma nanti apabila you have a lot, then it will be more easier. So this one is 0.125 plus with 0.1, so equal to 0.225. Okay, so now you have to find the absolute error. So absolute error, exact minus approximation. So exact is 0.222, 2 minus 0.22, sorry, 225. Zero point zero 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 28. Three. Okay. No, it should be 28. Okay. Now the first one is linear, and then change to the second one, n equal to 2 for the quadratic. Okay, so that means we have 3 data point. Okay, so if let's say 3 data point, 1, 1, 2, 3. So until this one. So include 3. So if you want to draw the table again, also can, or you just want to write it back. Okay, so if you want to draw the table like in the example in the book, so let's say I draw back based on 3 data point that we need. Oops. Mm-mm-mm. It's become auto like this. This one, this one, this one, this one. Too big. Just now, let's say I, x, and then this one is fx. Okay, so I'll start from 0, 1, 2, because we n is equal to 2. So 3, 4, 5. So the value just now 0 0.2, 0 0.2, 0 0.25, 0 0.2, and this is 0 0.3333. Okay, so now we want to get the function fx is p2x equal to L naught x times with fx naught plus with L1x times with fx1 plus with L2x times with fx2. Okay, then saya tulis sini continue here because it's a bit longer. So I put this one. L naught is, because we have 3, okay, start with the x naught minus x1, x minus x1, x naught minus x2, x minus x2. Okay, f x naught, f x naught. Okay, plus with x1 minus x naught, x minus x naught, x1 minus x2, x minus x2, f x1 plus with x2 minus x naught, x minus x naught, time with x2 minus x1, x minus x1, f x2. So like this. So ganti masuk the value of this one. So you just change that. So this value is x naught is 0.3333, and then the value of this one x1 is 0.25, and this one is 0.2. Okay, so this one x, this one p2 4.5. So x is 4.5 minus x1 is this one 0.25. Okay, divide by x naught is 0.333 minus 0.25 time with 4.5, 0.2, 0.3333 minus 0.2 times 0.3333 plus with this one. Okay, if let's say you don't want, okay, just ganti, else just use calculator. This one I use this calculator. This one calculator, I say this one, I will use, make this one a, this is a, this is b, this is c. Okay, and then x is 4.5. So it's pecahan, sorry, it's pecahan. So x alpha x minus alpha b, alamak, alpha, oops, sorry, alpha x alpha x minus alpha b. Then at bottom here, this is alpha a minus alpha b. Oops, alpha b. And then time with alpha x minus alpha a alpha no alpha c, and this is alpha a minus alpha c. And here the top, so this one. So I will calculate, start with the x equal to 4.5, and then the value of b, the value of b is 4. Then the value of c, b is 4, c, with c, a is 0.3333, and then c is 0.2. So get negative. So this value, negative 4.3988. Okay. And then this one, kalau nak tanah ganti. Okay. This value, calculate. X is 4.5. Now b is here. B is x naught, 0.3333. And then a here is like x1. X1 is 0.25, 0.25. And then c is this one, x2. Sorry, not 0.25. Why I put 0.2? Sorry, it's 4. C is 5. Wait, again. Just now x is 4.5, correct. And then b. B dah silap lah tadi. So b is basically this one, right? B is this one, x0. X0 is 3. So, and then a become at here, right? Now it's become x1. X1 is 4, correct? And then this one, the value is 0.75. Now this one. So sekarang ni, this is x, this is b, this is a, this is b. Okay. So dah tukar. Sekarang x kita masih sama. Cuma b. B now is x0. So x0 is 3. Correct. And then a now is x2. So a is x2. That means this one 5. And then c now here. This is c. C is x1. So x1 is 4. So we get here, this is 0.375. Okay. So yang ni saya sambung saya terus tulis 0.75 times with the value of y plus with 0.375 times with 0.2. So see, what do we get? Negative 4.3988 times with 0.333. Okay. Is it the value that you get? It's not the same. Do I calculate wrongly? in the books. Oh, I already just now why I put the value of y. Oh, okay, sorry. This one is why I put the value of y. It cannot be y. It should be value of x. It should be this one. 4 minus x1 is 4. And then this one x0 is 3. 3 is minus 4. This one is 5. And this one 4 minus 5. Alamak. Why did I calculate like this, eh? Just now is correct already. This one is not correct. Yeah. So this is wrong. This is wrong. So let's do again this one. Calculate. So x is still 4.5. B is x1. X1 is 4. And then A is 3. C is 5. So this is negative 0.125. Sorry. I'm wrong. Okay. So this one, negative 0.125, 125 5 times 0.333. Then you get negative 0.0417. So just now, and this one 0.75 times with 0.25, get plus with 0.1875. And then this one 0.375 times 0.2. So get plus with 0.075. And then this one add together plus 0.1875 minus 0.0417 and get equal to 0.2208. So we find the absolute error 0.2222 minus 0.2208. So it becomes 0.0014. So just now the absolute error is 0.0028. Now is 0. So it's smaller. So when we do more value, that is more smaller. So after that, we go to the n equal to 3. I write over here. N equal to 3. That means cubic approximations. Cubic, that means we have 4 data points. N plus 1, 4 data points. 4 data points. So you look at here, that means start from 2, 3, 4, 5. Okay. Let's copy this one. That means we have the x0. The draw table. Saya besarkan. So that means we have I 0, 1, 2, 3. Okay, and then x start from 3, 4. Start from 2. 2, 3, 4, 5. And then I have x. This one delete. Never mind. Okay. This one f xi. So the value is 0 0.5, 0 0.3333, and then 0 0.25, 0 0.2. Okay. So fx equal to p3x equal to L0 x fx0 plus with L1 x fx1 plus with L2 x fx2 plus with L3 x fx3. So now this one x0. So start with the x0 minus x1, x minus x1, x0 minus x2, x minus x2, x2, x0 minus x3, because we have until x3. X minus x3 times the value of f x0, 0 0.5, and then plus for the L1, x1 minus x0, x minus x0, L1 minus x2, x minus x2, x1 minus x3, x minus x3 times the value of the value of y, 0 0.3333, plus with x2 minus x0, x minus x0, x2 minus x1, x minus x1, x2 minus x3, x minus x3 times the value of y, 0 0.25, plus, now it's x3 minus x0, x minus x0, x3 minus x1, x minus x1, and this one x3 minus x2, x minus x2, times the value of y when x equal to 3, x3, that means 0 0.2. Okay, now find value of this one. Okay, so saya jadikan this formula, x minus b, a minus b, this one a minus c, x minus c, a minus d, x minus d, like this. So using the calculator, put the equation alpha x minus alpha b, this one alpha a minus alpha b, okay, and then alpha x minus alpha c, alpha a minus alpha c, and then time with alpha x minus alpha d. Here is alpha a minus alpha d. So I press calculate. So x is still 4.5, and then value of b. Now b here is x1. B is x1. So x1 is 3. And then a is 2. A is 2. The value of x2 is 2. Okay. And then x3, x c, this one x2 is 4. And then x3, d is x3 is 5. Okay, so I get this value is equal to 0.0625 times with 0.5 plus, so the next one I will use the same formula. So now x is still the same, 4.5. Okay, sorry. And then go down, b is here, x0 is 2. And then a is x1. x1 is 3. And then c is x2. x2 is 4. And then last this one, x3 is 5. Okay, so get negative 0.3125 times with 0.3333 plus, continue, use calculator. This one yeah, start from the calculate. X is still 4.5, and then b. Now here, this one, look at this one. Okay, and then if you don't know, you just compare to this equation. Okay, so look at this one. b is here, so that means b is x0. x0 is 2. Okay, and then a here, a is x2. So x2 is 4. So x2 is 4. C here, x1. So x1 is 3. And then last x3 is 5. So you get 0.9375. Alamak. 0.9375 times with 0.25, and one more. This one, the last one. This one. And then again compare with these equations. And then calculate again. X is still 4.5. Now b, look at here. B is now is x0. So x0 is here. x0 is 2. Okay, go to. So a look at here. A is x3. So x3 is 5. Okay, c look at here, x1. So x1 is 3. And then d is here, x2. So x2 is 4. So now become 0.3125 plus 0.3125 times this 0.2. So, and then calculate. 0.0625 times 0.5 minus 0.3125 times 333 plus 0.9375 times with 0.25 plus with 0.3125 times with 0.2. So you get the value is 0.2239. That means 224. Okay, so find the absolute error. So just now is 0.14, this is 1.18. Is it correct or not? 0.0018. So, and then this one is the cubic. And the last one is the quartic. Last one is quartic. When n equal to 4. N equal to 4, that is a quartic. Quartic. So quartic. So that means for the quartics, it will passing through 5 points. So 5 points, 5 data points, passing through 5 data points. So we will use all the data points that given, basically. So all the data points that given, this one. So 1, 2, 3, 4, 5. So all of this data point. Okay. Okay. So this one. So we'll use this table. So the fx will be, that means f4 actually. Fx is equal to p4x is equal to, okay, L naught x plus with fx naught plus is L1x fx1 plus with L2x fx2 plus with L3x fx3 plus with L4x fx4. And then we expand, become x0 minus x1, x minus x0 1, this one, x0 minus x2, x minus x2, x0 minus x3, x minus x3, x0 minus x4. Okay, this one will be at 0, 1, 2, 3, 4. I, okay? So x4, x minus x4. So totally we got 4 until 4. So time value of fx0. So the value of fx0 is 1. Okay? Plus with x minus x0, x1 minus x0, x minus x0, x1 minus x2, x minus x2, x1 minus x3, x minus x3, and then x1 minus x4, x minus x4, times with the value of x1, 0.5, plus x2 minus x0, x minus x0, x2 minus x1, x minus x1, x2 minus x3, x minus x3, x2 minus x4, x minus x4, times the value of fx2, 0.3333, plus x3 minus x0, x minus x0, x3 minus x1, x minus x1, x3 minus x2, x minus x2, x3 minus x4, x minus x4, times value of fx4, 0.25, plus with x4 minus x0, x minus x0, x4 minus x1, x minus x1, and then x4 minus x2, x minus x2, and then last one, x4 minus x3, x minus x3, and the value of fx4 is this one, 0.2, 0.2. Okay, so I will use the calculator. X minus b, a minus b here, x minus c, a minus c, a minus d. One more. Got e or not? Calculator got e or not? Okay, got until f. X minus e, a minus e. This one. So using the calculator, I will use this equation. Okay, pecahan alpha x minus alpha b, alpha a minus alpha b, and then alpha x minus alpha c, alpha a minus alpha c, alpha x minus alpha d, alpha a minus alpha d, alpha x minus alpha e, and then alpha a minus alpha e, and then press calculate. So same, x is still 4.5, and then b. Now look at here, the first one, b is x1, so x1 is 2, and then a is this one, the value of a, x0 is 1, and then c is x2, so x2 is 3, and then 4, and then e, that means this one, x4, so x4 is 5. So we get negative 0.0391. 0391. Negative 0.0391 times with 1. and then plus, use the same equation. Now x still 4.5, and then go to this one. Refer to the second row here. This one, and then we refer to this one. Check. So here b is x naught. So x naught is 1. And then a here is x1. So x1 is 2. And then c is x2. So x2 is 3. Correct. Sorry. The x2 with c, and then d. Okay. D is x3, 4. Correct. E is 5. Okay. Correct. So you get 0.2188. 0.2188 times with 0.5 plus, now we refer to this one. Okay, refer to this one, to this one. Let's calculate. X is still 4.5. Now b is x naught 1, and then a is x2. So x2 is 3, and then c is x1. So x1 is 2. Basically, this one is 4, and this one is 5. So you get negative 0.5469. Negative 0.5469 times with 0.3333 plus one more is 2 more actually. Plus with this one, calculate again. Look at here. X still 4.5. B, okay, so B is still x naught. X naught is 1. So A is now x3. So x3 here is 4. Wait. A is x4 is 4. X3 is 4. And then C is here, x1. So x1 is 2. D, here, x3. Sorry, x2. Okay, so kita ulang balik. That's what's happening. Okay, so x is 4.5, and then b, look at this one, Now it's this one already. B is x naught, that is 1. And then A is x3, so x3 is 4. C is this one, x1, so x1 is 2. D, x2, so x2 is this one. X2 is 3. And then E, this one, x4. X4 is, sorry. Why x2 is, this one, x2 is 3. Okay. X4, no, this one, x4 is this one, 5. Correct already, So we get 1.0938. 1.0938 times with the 0.25, and then last one saya pun pening, so kena refer yang ni this one, now refer to this one. So this one, calculate again. X still 4.5. Now A is x4 already, so now x4 is 5. Okay, A, bukan B is x0. Silap, B is x0 is 1. Lepas tu A is x4 is 5. Lepas tu C is x1. x1 is 2, d is x2 is 3, lepas tu e is x3 is 4. So we get 0.2734, 0.2734 times with 0.2. So calculate semua tu lah. Negative 0, negative 0.0391 times with 1 plus with 0.2188 times with 0.5 plus with negative minus lah 0.5469 times with 0.333 and then plus with 1.0938 times with 0.25 plus with 0.2734 times with 0.2. So we get 0.2162. 0.2162. And then the absolute error. 62. What did I get? In the book is, oh, okay. Haven't round up because 21614. So this is 1, 1, 4. So absolute error is 0.2222 minus 0.2161. Okay. So now is the end of this one. Maybe we try another simple example before we stop. Let's try. How about we try example 4.4. Okay, let's try example 4.4. Okay. Given a set of data shown in figure 4.3, approximate f1.5 using Lagrange interpolation. Now we have how many points? Calculate 1, 2, 3. We have 3 data points. So that means n is 2. Okay. And then we want to know when x is 1.5 here, what is the value of y? Okay. So now maybe we can do a table. Draw a table first. 1, 2, 3, 1. So let's say this is I 0, 1, 2, and then x. The value of x, look at here. The first one, x is 1. Here, x is 1. The second point, x is 2, 0.3. So this is a fxi. So when this one is 2, this one is 3, and this one is 7. Okay. If you want to draw the table, you can draw. If not, you just can also write like this. So that means start from point number 1, we have 1, and then 2, and then point number 2, 2, 3. Point number 3 is 3, 7. So you have to know this one is x0, fx0, and this one is x1, fx1, and then this is a x2, fx2. Okay, so now we have to find the so if you don't want to do a very long, you can step by step find the L first, the weighting functions, and then after that only combine. But I will combine all because I'm lazy. So now we want to find f 1.5. That means we need to find p2. Right? Because n is 2. P2 1.5. So equal to L naught x f x naught plus with L1 x f x1 plus with L2 x f x2. Okay, so this is the polynomial functions formula of this Laglash interpolation polynomial. Okay, this Laglash interpolation. Okay, so now start with this one. You will become x naught minus x1, x minus x1, x naught minus x2, x minus x2, okay, time value of f x naught, that is a 2, plus, okay, I put down here, plus x1 minus x naught, x minus x naught, x1 minus x2, x minus x2, the second value is 3, plus x2 minus x naught, x minus x naught, x2 minus x1, x minus x1, time value of 7, like this. Okay, so I will use this one become x minus b a minus b time with x minus c a minus c. So using this one, the first one, and compare this one. So alpha x minus alpha b, this one alpha a minus, sorry, alpha a minus alpha b. Okay, tutup darab alpha x minus alpha c a minus alpha c. Okay, so calculate. Now x is 1.5. 1.5. B, the value of B here, x1. So x1, this 2. A is x0, this 1. C is this one, x2. C, right? C, x2. So x2 is 3. So kalau tak, you nak tulis macam ni pun boleh. That means x2 is 3. So you get 0.375. Equal to 0.375 times with 2. And plus, now, refer to the second one. This one. Calculate. X is still the same, 1.5. And then, now B is x0. x0 is 1. A is now is x1. So x1 is 2. C is the same. So we get 0.75. Time with. So now it's the last part here. So calculate. X is still the same, x 1.5. Now B is x0, 1. And then A is x2. So x2 is 3. and then C here is a x1. So x1 is 2. So get negative 0.125. Then calculate 0.3775 times 2 plus with 0.75 times with 3 minus 0.125 times with 7. So we get 2.125. 4.3. Where's the answer? Huh? It's simple. Is it correct or not? 4.4. Why the answer is 2.215? It should be 2.125. Right? 0.375 times 2, 0.75 times 3, 0.125 times 7. Should I calculate again? Time with 2 plus 0.75 times with 3 minus 0.125 times 7. Yes, answer is 2.125. 2.125. But the book is 2.215. Maybe it's mistake. Okay. So that's all. I hope you understand for the Laglash interpolations. So the first and foremost, you have to make sure how many data points. That's because we want to estimate, we want to set the n. So n plus 1. So what you have to know is n plus 1 is the data point. So if that the data point got 4, that means the n is 3. So like this one, we got 3 data points. The n is 2. So that means we have to do the polynomial until the polynomial function until p2x. So when we extend, that means we have L0, L1 until L2, depending on the number of n. Okay, and then solve. So we will substitute the value of x based on the value that we want, this one. So now let's say you want to find the value of y when x is equal to 2.7, then you just key in the value 2.7 here. 2.7, 2.7, 2.7, 2.7. Okay, so that's all for today.